Hello, so what we're going to do today is section 2.6, finding rational zeros. And we're going to actually be finding all the zeros. And we're going to skip the rational root theorem, rational zero theorem, just because it's not super useful and we have better tools at our disposal. So that's what we're going to use today. And as you might notice, I have my graph or my paper here. It says page 32. Mine is slightly different than yours. For instance, I'm starting question number 5. It says find all real zeros of blankety blank. And then yours says first list the possible rational zeros. But what we're going to do, I want you to change that. First, we're going to list the suspected zeros. And then we're going to prove that they are zeros. That's the idea. And you might notice up at the top, I have another tab open, which is our Desmos graphing calculator. And that's what we're going to use in order to find what we suspect are our zeros. So what we're going to do is take this first equation, x cubed minus 8x squared plus 11x plus 20. And we're going to hop on over and we're going to type that in here. X. This is hard to do with this. Pardon me, guys. X to the third power. I'm going to just use my actual keyboard. Minus 8x to the second plus 11x plus 20. So here we have a graph. You can see this shape. It's a squiggly shape. This is a pretty classic shape of a cubic polynomial. Where it goes up and back down and back up again. And we are looking for the zeros. Hopefully you know where to find these zeros because these are the same place that we find zeros of parabolas way back in our first chapter. And that is where it crosses the x-axis. So we have these 3 zeros right here. So we're not just going to take the word for it, but this is what we're going to list as our suspected zeros. And we're going to prove it using synthetic division. So -1, 4, and 5 are our suspected zeros. So go back here. -1, 4, and 5. Those are our suspected zeros. And now what we're going to do is we are going to do synthetic division to prove that they are zeros. So I'm going to take my function, 1x cubed minus 8x squared plus 11x plus 20. And I'm going to write the coefficients, 1, -8, 11, and 20. And in the corner, I'm going to put one of my suspected zeros. So I'll just start with a -1. And I'm going to do my scientific notation. So this goes, bring this one down, and I get a 1 multiply -1. -9 multiply +9. 20 multiply -20. And I get a 0 for my remainder, which means that it is, in fact, a 0. I know that it works. I can circle it. It is, in fact, a 0. And now I'm going to try it with my other suspected zeros as well. The trick is here, though, that you don't have to go back and start over every time. In fact, it's better if I now put another little box right here and I put my next 0. And I am going to go into the quadratic that's left. So I'm going to go again, bring down the first one, 1. 4 times 1 is 4. I have a -5, and 4 times -5 is -20. And again, I have a remainder 0, which means that 4 is also, in fact, a 0. I've proven it just now. And then you could do it again, but what this means is x minus 5, because that's my remainder, my constant, and that's my x. So if I have x minus 5 equals 0, I know that x equals 5. So that is my third 0. So we break it down until it's smaller pieces. You don't have to go back to the beginning every time. All right, let's try. So the zeros, let's take a look at this. Our zeros are then, for sure, -1, 4, and 5. And I just want to be clear, our factors, if I were to write this in factored form, x minus 1 is the factor x plus 1. I'm sorry, 0 of -1 is the factor x plus 1. And then the 4 gives me a factor of x minus 4. And the 5 gives me a factor of x minus 5. So if they ask for the factors, this is what we need to do. If they ask for the zeros, that's what we need to do. Let's try question number 6. So we're going to make a spot for suspected zeros. Zeros. And then I'm going to type this function into my Desmos calculator. 2x to the third plus 3x, x squared minus 11x minus 6. Okay, so it's looking pretty good here. I've got a -3, a -0.5, and a 2. So -3, 2, and -1/2. -3, 2, and -1/2. Those are my suspected zeros. I'm going to go ahead and do my synthetic division. 3, -11, and a -6. I'll start with my -3. 2, -3 times 2 is a -6. Just run my arrow there. It's a -3. -3 times -3 would be a +9. And add, I get a -2. -3 times -2 is a +6. And I add, and I get a 0. That's good. That's what I wanted. I just showed that -3 is in fact a 0. At this point, you do have the option. If I were to put this back into a quadratic or into regular form, I would have a quadratic equation, which you could factor, or we could try our next one on our list, and I just put it right here, and I use this 2, -3, and 2. So let's give that a try. I think that'll be easier than factoring a quadratic at that point. So 2 times 2 is 4. -3 plus 4 is 1. 2 times 1 is 2. Oh, and here we have a 0. Now I'm going to take this last one, and I'm going to change that to 2x minus 1, because that's what it is. There's my remainder of 0. My constant is 1, and that's just going to be x, which I would set equal to 0. I add 1 to both sides, and I get 2x equals 1, and x equals 1/2, which is what I wanted. So my zeros are -3, +2, and -1/2. I just verified those. I proved them. I looked at the graph, but just looking at the graph's not enough. I'm proving with synthetic division. And then my factors, if they asked for that, would be x plus 3, x minus 2, and I don't want to write x minus 1/2 because that wouldn't be a factor. This should be this form right here. If you have a fraction, it's really going to look like that, 2x minus 1. Okay, so those are the zeros. Those are the factors. Let's take a look at this next one. Why don't you try question number 7 on your own for a second, and then unpause and come back, and I'll show you how I did it. All right, so if you've done it here, we're going to type our function in, x to the third power minus 8x squared plus 5x plus 14. And I see -1, 2, and 7. So our suspected zeros, I keep doing that, of -1, 2, and 7. So we're going to go ahead and list our numbers: 1, -8, 5, and 14. And put a -1 over here. Bring down your 1. Multiply, you get a -1. Add -8 times plus -1, -9. Multiply, you get a positive, and you get a 14 when you add. -1 times 14 gives you a -14. So that's a remainder 0. I've proven that -1 is in fact a 0, and I can move on from there. But I am going to show you this way, just in case. You can continue to do synthetic division. But now we have a quadratic. That's your constant, your x and your x squared. So if this is easier to you, you can change this to this the quadratic right there, and then factor it, and you get x minus 7 times x plus, or sorry, minus 2. And both of those you would solve, you get x minus 7 equals 0 and x minus 2 equals 0. So you get your x equals 7 and your x equals 2. So that's another way to show that 7 and 2 are in fact zeros. So we have our zeros, which are -1, 2, and 7, and our factors, which we just said x minus 2 and x minus 7, but we also have that -1 as a 0, so that'd be an x plus 1 for a factor. So that's what we have for number 7. On number 8, it is a little bit different. First of all, it's a quartic. There's 5 terms, so it's not anything else. So what we're going to, when we graph this, we are going to have a different shape than we've seen. 2x to the 4th plus 5x cubed minus 18x squared plus minus 19x. My goodness, so many terms. Oh, that's not x squared. So 18x to the 2nd. There we go. Minus 19x plus 42. And if we zoom out here, we look at this. This is a very interesting little shape. Instead of it going up in one direction and down in another, it's more like a W shape, but an uneven W. But we can see we're still going to get 4 zeros. It crosses the x-axis 4 times. Oh, so this one is a decimal, and we're not going to write down decimals, because if we see a decimal, unless it's an easy one that's like 1.5 or 2.5 or something like very straightforward, that would be a fraction, this is probably not rational, and it's going to have a square root in the answer if you have that long decimal. 1.5, we can write that down as 3/2, or 1.5. -2 we can write down. And here we have another, and we'll get this, it's very suspicious here. They have the same ending, which means it's probably going to be a plus or minus situation when we took the square root, if we end up with those same things. So we're going to write down the ones that we do suspect, -2 and 1.5, which is the same thing as 3/2. So suspect -2 and 1.5. And so that's what we're going to start with, the easy things, -2. So that's 2, 5, -18, -19, and 42. And that's 2. So that's going to be -4. When you multiply, add -2, that'll be -20, +40. And that should give us a 21. When we multiply by -2, we get a -42, which is in fact 0. So that's good. Now, we don't usually use decimals with synthetic division or fractions, but we can. If it's a terminating decimal. If we had that other decimal where it was just kept going on and on, eventually got rounded, it wouldn't work. But if it is an exact decimal, it is possible. So we can go here with our 1.5. 2 times 1.5 is going to be a 3. That gives me 4. And then 4 times 1.5 will give me a 6. It's a -14 when I add. Now, -14 times 1.5, if you don't have a calculator, you can think of that as like times 3/2. And so that's going to be a -21, which is what we wanted it to be. So that's a 0, because that's a remainder 0. I'll get rid of that so we don't get confused. At this point, because my other 2 suspected zeros, these I know are real, my other 2 suspected zeros were these weird decimals. I am not going to try to plug them in, because it's not going to work out to be exact. Instead, I'm going to make this back into a quadratic. 2x squared plus 4x minus 14. And then I'm going to set that equal to 0. And now the only way I am going to be able to solve that is if I use the quadratic formula. So that's exactly what I'm going to do. When I have a quadratic and I don't have any nice looking zeros, any rational zeros, I have to use the quadratic formula, I'm going to say negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 14. That's my 4 times 2 is just a times c, which is negative 14. And this is all over 2a. Whoops, sorry. Of course, a is 2. So we're going to do 2 times 2. And that simplifies. You're going to get negative 4 plus or minus the square root of 16. And then when I do negative 4 times 2 times negative 14, I'm going to get a plus something. I think it's going to be a 112. That looks right. All over 4. And this, I'll bring it up here. I get x equals negative 4 plus or minus the square root of 128 all over 4. All right, so 128 is not a perfect square. So I would then have to take this over here, 128. Oops. That's going to be 4 times 32, and 4 times 32 is 4 times 8. And 8 is 4 times 2, and all the 4s are 2 times 2. So 128, oops, is 2 times 2. A lot of 2s. 1, 2, 3, 4, 5, 6, 7 2s. 1, 2, 3, 4, 5, 6, 7. So 1. All right, got 3 pairs outside, 1 inside. So x equals negative 4 plus or minus 2 times 2 times 2 on the outside gives me an 8 on the outside, and a 4 left over on the inside, and a 4 underneath. Notice it was all positives underneath the square root sign, so I don't have any imaginary numbers. It's just a simplified square root, which we've had to do a lot of. And then that can be simplified if I divide each of those terms by 4. I'm going to end up with negative 1 plus or minus 2. Oops, this should have been root 2. Sorry. 2 root 2 over 1. So that's my answer. My last 2 zeros. Now, that can't be simplified any further, but if you did type that out, you would get 1.828, blah, 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 and negative 3.828. So those are our irrational zeros. So our zeros are negative 2, 1.5, and then negative 1 plus or minus 2 root 2. That gives us 4 zeros. Our factors, x plus 2. 1.5 is the same thing, as I said, as 3 halves. So that is going to be 2x minus 3. Sorry, that is a toughie part. You would have to change that back to a factor, 2x minus 3. If you solve that, you would get 3 halves. And then for those irrational ones, you have to leave it as your quadratic, your 2x squared plus 4x minus 14. Because this can't be factored, which is why we ended up with irrational solutions. All right, there we go. Those are your answers. That's all the work. Good luck.